Hello, good morning. Yeah, Dinesh. Hello, Dinesh. Students, good morning. All of you. Very good morning. I think all of you, please raise your hands. Who are active in the class? Raise your hands. Those who are raising the hand, they are active in the class. Only 8. All of you raise your hands. Avinash, Shreya, Shiva Reddy.
Yes, sir.
Please raise your hands. I request all of you to raise your hands. Still few more. CR, Bhavya. You are inactive in the class, Bhavya. Always you are inactive. Vardhan, Nikhil, Dinesh Reddy, Shiva Reddy. Raise your hands. Already in between class to class 10 minutes there, na? Why all people are joining late? Still Suryanarayan Raju, Nikhil. Yes, quickly down your hands. Quickly, do it fast. $16, $47, $39. Down your hands. Down. Arey Baba 16. Okay. Let me start the class. Are you ready? Are you ready?
Yes, sir.
Okay then. See, so yesterday we have discussed some topics. So I forgot what topics I have discussed. Okay. So let me remember. So I think I will ask Bhavya. Bhavya, can you repeat what are the topics just I covered in the last class?
Sir, you said about pass transistor, sir, MOS transistor transconductance and output conductance, sir, and you said about ideal inverter introduction, sir, and NMOS inverter types, you said, sir, NMOS inverter with resistive load and depression load, like that, sir.
Okay, then good. So, okay, 1 minute. So I will start with NMOS inverter. Already here is there. So NMOS inverter.
Saturation load.
NMOS inverter. We have a resistive load. We have a enhancement mode load and depletion load. So of course, in the enhancement load, we have two types. One is a saturation load, and one was a linear mode. Okay. So I will go to I will open one whiteboard. Yes. Yeah. Now, so what is the first one? NMOS inverter with resistor load we'll discuss first. NMOS inverter, NMOS So inverter with resistive load. Resistive load. Yes. These people are joining very late. Okay. Suryanarayan Raju. Roll number 2. Roll number 2. Suryanarayana.
Yes, sir.
Yeah. So you are today's co-host. Okay. So allow the students who are in the waiting room. This is our job today. Okay.
Okay, sir.
Yeah. So NMOS inverter. This is my MOS transistor. 1 minute. Okay. Resistive load. Resistive load. I think this is very familiar to you because of we are always using the resistor as the load for any amplifier. So this is also just like that. One minute. It's moving. Okay. So resistive load. Okay. This is my MOS transistor. What type of MOS transistor is? What type of MOS transistor is? Anybody can name it? Hello? Hello? So anybody can open your mouth. Oh, why are you so dumb? Huh?
Nmos.
This is, yes, correct. This is the load. Load. Okay. And so the connections between these. So this is, you can collect the output here. So V out, and it is the input voltage V in. Okay. This is ground. This is the VDD. This is the RL, you can say. This is the transistor M. So I think you understood that this is the what NMOS transistor circuit. NMOS transistor circuit. Okay. This is the your NMOS transistor. Okay, N type. So now what I want to discuss with you is this is the, see, this is the voltage between the gate and source VGS. Okay, gate and voltage. So whenever your input voltage V in, okay, V in is less than VTH, threshold voltage of this NMOS transistor, VTHN, you can say. So what happened with this condition? This transistor will not be switched on, so that M is equal to off. Whenever M is off, this circuit is looking like this. So there is a load resistor, and the transistor is open. The transistor is open like this. So here you need to collect the output V out. So this is the VDD supply, and this is the RL load. You are collecting the output here. as I told you, here is some capacitor should be there. So that is a load capacitor. We need to connect it here. See here. Now what happened? Because of this transistor is open, the transistor is open, the current is flowing like this. The current is flowing like this. So the capacitor is going to be charging. The capacitor is going to be charging. So therefore, your Vout, output voltage, is equal to supply voltage VDD minus drop across this, what is that one? Load resistor RL. And the current is, say, ID current. You can say the ID current. So ID is multiplied with the RL. This is the condition. Okay. This is. So whenever input is less than VTH, in your language, you can say it is a 0. It is a 0 input voltage. What happened? So the output is VDD because the drop across this one is considered as a very small. So that output is VDD. So that means input is Vin is equal to 0. Then you got, so Vout is equal to, so VDD means 1, logic 1. Okay, logic 1. This is the inverter operation. Second case, whenever your input voltage is greater than VTH of the transistor, this transistor is driven into the saturation region. Whenever it is saturated, I think it can be act as a switch. So that now your transistor is like this. So with this, the transistor is like this. It's closed. So this is the VDD. And here you are going to Vout. Already here is a capacitor which is already fully charged. So now the current is passing like this. Whenever current is passing like this, okay, what happened? There is no drop is available here. Because of this capacitor also discharging like this, whatever the charge is here. So that you can say, so Vout is equal to, so the total charge, whatever the charge here is there, that entire charge is going to be discharging. So that there is no question of the voltage at the V0 is very, very small because the charge already decreases. So that, so Vout is equal to only, that means 1 minute, 0. In this case, you can say Vin is equal to 1 and Vout is equal to 0. This is okay. So now if you try to draw the characteristics of this NMOS inverter with resistive load, so then you will get like this. See, this is the input voltage. This is the output voltage Vout. For an input voltage of low, maybe, so this is the 0 volts. This is the threshold voltage of the NMOS transistor. This may be. Okay. Now, suppose input is 0 up to threshold voltage, then it may be like this characteristics. These are the input characteristics. The corresponding output characteristics are like this. Yeah. So for low input, we get the high output. For high input, we got the load. This is the output characteristics. This green indicates the output voltage and red indicates the input voltage. This is the way you are getting the characteristics. So, do you understand this one? Hello? Are you understand?
Yes, sir.
Okay. So, what are the disadvantages with the resistive load? We'll discuss now. The first main disadvantage of this resistive load is, so using of resistor as the load here. Using of resistor load is what? The resistors occupies more area on the silicon. Silicon. So this is the main disadvantage. Understand or not? If you want to make the resistor, if you want to fabricate the resistor, so it occupies more area on the silicon, on the IC, in the IC. That is the disadvantage of the resistive load. Got my point?
Yes, sir.
Okay, anybody having doubts here? So I will move to the one more inverter. That means either enhancement mode or depletion mode. Okay, if it is no doubt, then I will move to the next one. Yeah. So this is the NMOS inverter with saturated load. So here is a, if you see this one, this circuit is what? NMOS saturated load. This is the one NMOS transistor. This is one more NMOS transistor. Okay, whose source is this grounded? M1 or Q1 source is grounded, and drain is this is the drain. For the Q2 transistor, this is the source and this is the drain. The gate of the Q2 transistor is connected back to the drain, so that the VDD is applied to both drain as well as the gate of the Q2 transistor. Got my point or not? So what it means is, by doing of connection like this, the gate is gate of the load. This is the load. So in the place of load resistor, I am using the one NMOS transistor, which is operated in the saturation mode. Okay, so to operate the saturation mode, so the gate of the Q2 transistor should be connected back to the drain, and both are connected to the same supply. See, the VDD is applied or connected to both the drain and the gate of the Q2 transistor. So this is called the saturation load. So NMOS saturation load. Saturation load. Yeah. So in this, by doing the connection like this Q2 transistor is always in the saturation. Okay, here, so in the Q2 transistor, I am telling about you. So VDS. What is the VDS? Drain to source. This is the drain, this is source. Voltage is equal to. Okay, so VGS. Because drain and gate is connected to at the same potential. Okay, the potential between the drain to source as well as the gate to source, both are same. This is the equation. Okay, so VGD, gate to drain. This is the gate to drain. So gate and drain both are connected to the VDD, so that you can write VDD. Okay, so why? So V out, this is the V out. So V naught is equal to or less than, as long as V naught is less than, this is less than. So don't forget, here is a capacitor is there. Okay, CL. So as long as V naught is lower than the VDD minus, so VTH, here is both are N transistors, so that I can write the second transistor, VTH2. Okay, so while this condition is satisfying, so always the device in the saturation, Q2 in the saturation. Suppose if this condition is not satisfied, so I think the device will come out of the saturation. So since So VGS, gate to source voltage, is greater than so VTH2 in this condition. So gate to source voltage is, this is the V naught. So V naught means here voltage. So is less than VDD minus VTH. So the same voltage will be reflected to the gate also. So that it is more than this one, threshold voltage. Whenever a device is greater than the threshold voltage, input is greater than threshold voltage, definitely it is in the saturation mode. Okay. So and one more thing is, in this condition, so VDS, I am talking about only second transistor, why it is in the saturation mode. So VDS, okay, is greater than this drain to source voltage is also greater than, because V naught is less, so that this voltage is more. So VGS minus VTH2. So what are the conditions for the saturation? What are the conditions for the saturation mode? Any device, a MOS device should be operated in the what? Saturation mode. The conditions are two conditions I told you. Conditions for saturation. ఏంటంటే కండిషన్స్? సో Shreya, hello.
Yes, sir.
What are the conditions for the saturation mode? అంటే డివైస్ సాచురేషన్ లో ఉండాలంటే వోల్టేజెస్ ఎలా ఉండాలి? కండిషన్స్ చెప్పాను. 3 రీజన్స్ కి 3 కండిషన్స్ చెప్పాను.
V0 should be less than VDD minus VTH, sir.
VGS should be greater than VTH, first thing. And second thing is what? So your VDS should be greater than so VGS minus
VTH.
So yeah. Yes, Bhavya.
Sir,
Bhavya,
sir.
what is the name of this one? దీన్ని ఏమని పిలిచాను నేను? VGS minus VTH ని.
Sir.
రెండోసారి సార్ అనకూడదు, ఒకసారి అడిగి మీకు క్వశ్చన్ అర్థం అయితే. ఏంటి? VGS minus VTH ని ఏమని పిలుస్తాం? At least read whatever I wrote in the screen.
Overdrive potential, sir.
Overdrive potential or overdrive voltage అంటాం. VGS minus VTH ని. Okay, so these two conditions are satisfying because of this one. So VDS is VGS, both are same, and your VGD is JD means this one, both are same, VDD. And one more thing, and so this is the main thing. As long as your output voltage V0 is less than the VDD minus threshold voltage. VDD minus, of course you can write the VGS. VGS is how much? If you find the VGS here, VGS is nothing but V0, and VGS is nothing but this potential is VDD minus VTH. Okay, so that so your potential is less than this potential, so that what happened? So the Q2 is in the saturation. Okay, for example, because of this capacitor charging process, okay, if your V0 value is greater than this condition is, if it is volta, so VDD minus VTH 2, what happened? So your device is, it goes cutoff region. It goes cutoff region. Who will go to the cutoff region? Goes into cutoff region. ఎవరండి cutoff region లోకి వెళ్తారు? హలో లావణ్య, పవన్
Yes, sir.
ఎవరండి కటాఫ్ రీజన్ లోకి వెళ్తారు ఒకవేళ ఈ కండిషన్ సాటిస్ఫై అవ్వకపోతే?
V0, sir.
ఏ మైండ్ ఉందా నీకు? డివైస్ గురించి మాట్లాడితే V0 అంటావేంటి? V0 డివైస్ కటాఫ్ లోకి వెళ్ళడానికి. So suppose V0 is greater than VDD minus VTH2, who will go into the saturation cutoff region?
Q2, sir.
Q2. మాట్లాడేటప్పుడు కొంచెం ఆలోచించి మాట్లాడండి. Okay. So this is the what? I hope you understand. This is the NMOS inverter with saturated. What type of enhancement saturation? This both devices are enhancement type. This is also enhancement type MOSFET, NMOS transistor. This is also enhancement type NMOS transistor. Okay. Whenever your gate of the NMOS transistor is enhancement transistor is connected to the drain, it is in the saturation mode. Okay, in the saturation mode, since the two devices are connected like this, what happened? So the same current flows from this is the VD to ground. So whenever this transistor is on, the current ID2 is equal to ID1. Current ID2 is equal to ID1. Okay, so whenever this is always in saturation. Okay, then what happened? This device will be operating on the operator switch. Suppose your input voltage is here, come to the Q1. Suppose if Q1, that means V1 or Vi, we can say Vi is less than VTH1. VTH1. Suppose this threshold voltage is VTH1. If the input voltage applied at the gate is less than threshold voltage, this device Q1 is in the off condition. Q1 is equal to off cutoff region. So whenever it is off, this device is, I think, open circuit. Now the current is flowing like this through this device, like this. Current is flowing through the capacitor. Then the capacitor starts to charging. So whenever the capacitor starts to charging, the output potential is going to be rising. Whenever it is rising, I think the potential at this point is increases than this one. Then this comes to the cutoff region. Okay, and moreover, once the input voltage sufficient is more than the Vi is greater than VTH1, this device will be on. Q1 is equal to on. So whenever it is on and it is off, the current is the charge from the capacitor is going to be discharging like this. Whenever it is discharging like this, the potential at the V0 is going to be decreasing. Whenever this potential is decreased enough to make there is imbalance, that means this potential is more than this potential, then again it goes to the saturation. So in this way, you can have a inverter characteristics for the first. So when Q1 is off, this is charging means you will get the full VDD. Okay. So and whenever this is on, the current is dropping, so that you will get the low voltage here. Any doubts on that? Even doubt on that? Hello?
No, sir. No.
Yeah. So and one more thing, if you find what is that one characteristics? If you draw the characteristics, okay. So whenever Vin is, I told you, V input voltage is less than the threshold voltage of the first transistor. I am talking. So what I told you, Q1 is off. Q1 is off. Okay. So and of course Q2 is on. Q2 is equal to on. Okay. Clear. Then V out is equal to, generally we understood that, so VDD. But the thing is, you will not get the VDD because so gate and drain is connected to the VDD. Your output is, you can write VDD minus VTH2. So your voltage is, that means VDD is lower than one threshold voltage of the second device. So that in the characteristics I can write this is my input to output characteristics. So that means V in and this is my V out. Let us say this is my 1 minute. So this is my full VDD level. Okay, and this is my VTH1. So this is my VTH1. Okay, so whenever my input voltage is 0, input is less than this is the condition. Whenever the input is less than the VTH1, so the lower device will be off. So that output is equal to VDD, we thought, but output is what? VDD minus VTH1. So that in the characteristics you can write, you can show like this. So this is your output for the input lower than VTH value. So here is the gap between the full VDD. Okay. So and the whatever the actual output. This is the actual output. V out, actual output. So the difference between these two is so VTH2. Okay, later once your input voltage cross the VTH1 first device threshold voltage, the device into the switch on, and what happened? The output voltage is decreasing like this. That we want to discuss here. So whenever input voltage is greater than VTH1, your Q1 is on. Okay, Q1 is on. That means and QT is whatever the QT is off because your output voltage is going to be decreasing. So because it finds the lowest path always, so that Q2 becomes off. So that it finds the path like this. There is a cutoff like this. First device, upper device, lower device is close, and there is a capacitor. So the capacitor, whatever the charge in the capacitor is discharging through like this. So that the potential at this point V0 is going to be decreasing. So before short circuiting of this first device, lower device, this having the full VDD or VDD minus VTH charged. So once the low resistance path is established because of short circuit, so the capacitor is going to be discharging like this because above one is cut off. So that what happened? The potential of the V0 is going to be decreasing. This makes again the Q1 goes to saturation, Q2 goes to saturation. Okay, this is this one. So here, if you see the characteristics, there is no swing, full swing. Full swing means for the 0 voltage, you should get the full VDD as the output. For the VDD input voltage, you should get the 0 voltage. These are the full swings. Full, what are the input voltage? 0 and VDD are the input voltage. At the output also, you should get 0 and VDD. But here, you got the output is lower than the VDD. That means VDD minus VTH2 you got. But later, for the 0, for the high input, that means you will not get the 0 output. Rather. So something value will get. This is the what happened. You can say non-zero output. So this is the main disadvantage of the what? This NMOS inverter with enhancement load. Okay, in the saturated operation. Okay, this is the condition. Hello?
Yes, sir. Yes, sir.
Yeah. So this is the what? NMOS inverter. Remember, NMOS inverter with enhancement load and operated in the load is operated in the saturation mode. Okay. So what is the drawback? The drawback is if you observe these characteristics, so you will not get the full swing of the voltages. You will get, so for the low input voltage, for 0 input voltage, let us say for the 0 input voltage, you will get the output less than the VDD minus VTH1, VTH2 you got. For the high voltage, that means for high input voltage, means suppose input is equal to 1, means VDD, then your output is not 0. It has some value. So there is no, this is the disadvantage of this one. Disadvantage of this one is this much. What is that one? No full swing voltages at the output. Suppose if the input is 0, output is VDD. If the input is VDD, output is 0, it is called the full swing. But you are not getting here full VDD or full 0. You are getting the lower than VDD value as well as above the 0 value. This is the disadvantage. Okay. So and if it is fine, I will move to the one more thing, linear enhancement load. Okay, can I move?
Yes, sir.
Okay. So if you want, you can take a screenshot. No problem. Okay. So I will erase this. Okay. Okay. Now the third one is NMOS linear enhancement load. Yes. Okay. So here, very simple. The circuit is like this. This is one transistor. This is one more transistor. Both are N type, no doubt. Both are enhancement type, no doubt. This is one transistor M1, you can say. This is one more transistor M2, you can say. This is the supply voltage VDD, and this is counted. This is source of this one, drain of this one. So this is source of this one and drain of this one. Here, this is the input is applied here, V in. And the above one, okay, M2 transistor gate is connected to the some fixed voltage VGG. And you can collect the output here. You can collect the output. So, you know, here through the capacitor, this is the capacitor, it is always there. So, this is the V out. Yeah, this is. Okay. So, this is fixed voltage for the M2 transistor. To be keep in the M2 transistor in the linear mode. To be keep in the M2 transistor in the linear mode. Okay. So, the load should be always in the linear mode. So, whenever VGG, so M2 transistor gate potential is greater than, so VDD plus VTH2. Yeah, that is. Okay. So, now VDS, drain to source voltage of the upper transistor or low transistor is equal to. So, this voltage is VDD, this voltage is V out, in middle there is a VDS. Okay, VDD, so plus VDS plus V naught is equal to 0 as per KVL. So that now I want VDS means VDD minus V out. Minus V out. That is the this one. I am talking about only upper device. Okay, so and VGS means, see, this is the VDS, VGS, gate to source voltage. So VGS I can write, VGS is equal to, so this potential is VGG minus, here the potential is V out. V out, that's it. Okay, so drain to source voltage, gate to source voltage, you found for the what? Second transistor, upper transistor, low transistor. Okay, now this voltage, that means VGS may be greater than, okay, greater than, so VDD plus this one. So in place of I think in place of VGG I will write this one, VDD plus VTH2 minus V out. Suppose if VGS is more than this fellow, then this is in the linear region. Okay, so and VDS is already, you know, this is the VDD minus this one, so is less than, so VGS minus VTH2. So these two conditions makes the device is always in the linear region. The device, which device? M2 device in linear mode. That is. Okay. So now, okay, anyhow, so once you keep it is in the linear region, then you can start the what? Gambling with the M1 transistor. Suppose Vin is so less than VTH1. I think so M1 is off and V out is equal to V out is equal. This is off means the current is flowing like this to the capacitor. Instead of, so transistor M1, the current is flowing like this. Yes. So that here the potential is going to be increasing. So anyhow, V naught is equal to, so VDD. Generally we thought that. So, but here also you will get the output is VDD minus VTH2. Okay. So whenever your input voltage is greater than the VTH1 threshold of the first device, then M1 is on then so instead of current is flowing like this because of its on, so current is flowing like this from the M1 transistor, so that your output is, that means output voltage is decreasing, so that okay, so M1 is on and V out is equal to, again what happened, so you will get the 0, but you will get some voltage, here also same problem you got. So this is, if you find the characteristics like this, V input and V out, if you draw the characteristics, 0, okay, so and this is the, yes, so VDD, and this is the, so VTH1, and so you will get the output like this. Again you will get the lower output, so because of VTH2, this is the gap, that is the VTH2, and here is also non-zero output you will get. This is the non-zero for the high input, non-zero output, yes, you will get it. So here the disadvantage is, see, earlier these two terminals are tied together so that one supply is enough, but now these two terminals are not tied, so separate what sources are required, separate voltages are required to connect these two. For this one source to give the VDD, for this one more source to give the VGG voltage. So this is the drawback of this fellow. So anyhow, either in saturation mode or linear mode of enhancement load, we got the problem of this one. What? We will not get the full swing voltages at the output. This is the main issue of the enhancement load. NMOS inverter with enhancement load. NMOS inverter with enhancement load. We have two types, saturation and linear. But so those are failed to give the full swing of voltage at the output. Full swing of voltages at the output. Got my point? Hello?
Yes, sir. Understood.
Anybody having any doubt? Hemant Verma, nicely you are enjoying. Hemant Verma. Hemant. Okay. Sleep. Shiv Prasad, roll number 3.
Yes, sir.
So do you understand?
Yes, sir.
So what is the main drawback with the enhancement load transistor?
Sir, it is failed to give the full voltage of output, sir.
Okay. Mute yourself. Subramaniam.
Yes, sir.
So what about you? Do you understand?
Yes, sir. Understood.
So what is the main drawback of enhancement load transistor?
It is
In the
failed to
inverter.
give full swing output, sir.
Full swing outputs. Okay, good. Okay. So what is the disadvantage? Okay. Anik, roll number 6. Roll number 6. Roll number 6. Venkat. 9.
Sir.
Yeah. So what is the disadvantage of linear enhancement load in the NMOS inverter? Linear enhancement load, okay, NMOS inverter compared to the saturated enhancement load NMOS inverter.
Linear and most.
The question అర్థమైందా?
Sir, again, could you repeat the question again?
So linear enhancement load NMOS inverter, okay, saturated enhancement load NMOS inverter తీసుకుంటే linear enhancement load NMOS inverter లో disadvantage ఏంటి?
Disadvantage.
Shruti.
Yes, sir. In linear mode, we will be giving potential to the gate, but in saturation mode, it is directly connected to the VDD, sir.
I think it should be explained in a nice way. Na? It is very simple that extra one power supply is required for the linear enhancement compared to the saturation. This is the extra supply is required. Okay. VCC is one more supply is required.
Yes, sir. Yes,
Yeah. So the next one is next one. This is the what? So this linear saturated mode, linear mode, linear enhancement load of NMOS inverter. NMOS inverter. Yeah. This is the 1 TH1. He said this is the one device. So this is the non-zero output you got. So it must be touched like this. You should get like this. The cat should be like this, but you didn't get like that. Here is, and here is some losses are there. Okay. So that this is the what disadvantage in the linear. This one. Yes. So next one is, so instead of using enhancement load, so we can use the depletion mode. Depletion load. This is the NMOS inverter. No doubt at all. This is the source of this M1. This is the second transistor M2. But this is not, it is also NMOS inverter. NMOS transistor. But so it is the enhancement mode of transistor. This is the depletion mode transistor. So how can you make the difference? The difference you can see this thick line is there at the gate for the depletion transistor. So then the enhanced transistor. Okay, got my point? Hello? Hello? Pawan?
Hello, sir. Yes, sir.
Understand or not?
Yes, sir.
So how can you show the difference between the enhancement and depletion mode transistors? For the depletion mode transistor, the gate. So side the gate, you have a thick line. This is the depletion transistor. This is the enhancement transistor. See the difference. అర్థమైందా? మీరు డ్రా చేసేటప్పుడు డిప్లిషన్ ట్రాన్సిస్టర్ అంటే డిప్లిషన్ మాస్ఫెట్ ని ఎలా చూపించాలి, ఎన్హాన్స్మెంట్ ట్రాన్సిస్టర్ ని ఎలా చూపిస్తాం. సో sources are there. అర్థమైందా?
Yes, sir.
Yes. So in the whenever you are using the depletion transistor as the load, the gate should be connected to the what source. Gate and source is connected tight together like this here. Earlier you connected like this. Now you connect like this. Understand?
Yes, sir.
Okay. Yeah. So this is the now depletion MOSFET load. So this is the NMOS inverter with depletion load. NMOS inverter with depletion load. Okay, we'll see. So whenever this gate of this depletion transistor is connected to the this source, so it is always in the this M2 is always in the saturation, always in saturation. Okay, and this is the device, the lower device. This is the pull down. This is the pull up. Okay, pull down, pull up. Okay, so this is the load. Simply, this is the load, and this is the driver. Okay, whenever we see here, you can say for M1, I am talking about M1. See, this is the VDS. This is the VDS between this drain and source. You can have a VDS value. So VDS, and here is the VGS. But VGS is equal to gate minus source. Source is how much? V out. So VG minus VS. So VG minus VS. Both are tied together to V out, so that you can say VGS is equal to V out. Okay. So now is always V out. So come to the VDD. VDD plus VDS plus V out is equal to 0 as per the KVL. So now VDS is equal to, you can say VDS is equal to VDD minus V out. V out. Okay. So I think you get the result. Okay. Now, so come to the point. This is the M1 transistor. For M1, so whenever your input voltage is less than VTH1, VTH1. Okay. So that what happened? Your M1 is off. Whenever it is off, whenever M1 is off, I think there is a capacitor. I told you, the capacitor is going to be charging. Current is flowing to the capacitor, so that the capacitor is going to be charging. So current is flowing like this. So capacitor is going to charge. So with this, you will get the V out is equal to exactly VDD because of the saturation. Similarly, whenever V in is greater than VTH1, so M1 is on. Whenever it is on, the current, whatever the charged voltage across the capacitor, that will be discharging via M1 transistor. This will discharging via M1 transistor because of it forms always low resistance path. So both are grounded. But instead of discharging to the capacitor will discharge via M1. So that what happened? This output becomes V out is equal to. So I think you will get the low voltage, but some voltage will be dropped across this M1 is there. So you can say V out is equal to less than 0. That means greater than 0. Some greater than 0. Yeah. So if you come to here, if you see the characteristics, this is the input voltage versus output voltage. This is the VTH1. That means lower device M1 threshold voltage. Okay. So for the voltage less than the VTH1, this device is off. So that output is exactly VDD. So when the input voltage is greater than the threshold voltage of the M1, then this device starts to conducting and finally goes to saturation. So whatever the charge across the capacitor is discharging like this, so that this voltage across the capacitor is going to be decreasing. So that it is decreasing because of discharging, and finally you will get some voltage is there across the output capacitor. That is some voltage. This is non-zero output you will get. So what is the difference between the enhancement load and depletion load? So in both the cases, in enhancement load case, you have a I think so you did not get full full VDD and full 0. But in the depletion load, you can achieve the full VDD but not full 0. So I think out of two, one has been recovered and other thing is still there. Okay, got my point?
Yes, sir.
Yeah. So 37 members. Why? Okay, time అయిపోతున్నారు సరే చూద్దాం. సంకేత్ మాన్షి సింగ్ 54. Okay. Hemant 53. Santosh?
Sir, yes, sir.
Yeah. So here in the depletion ఏంటి
సార్ అంటే పార్టిసిపెంట్స్ తక్కువ మంది అన్నారు కదా సార్, అంటే డెల్లైట్ మాక్ ఇంటర్వ్యూస్ జరుగుతున్నాయంటే సార్.
సరేలే. సో ఇప్పుడు చెప్పు. సో ఇక్కడ ఎందుకు ఫుల్ వోల్టేజ్ వచ్చింది? వెన్ ఎవర్ ఇన్పుట్ వోల్టేజ్ ఇస్ లో, ఓకే, దిస్ M1 is off, M2 is in saturation. ఈ కేసులో యూ గాట్ ద ఫుల్ VDD అవుట్పుట్ లో వచ్చింది. ఎందుకు వచ్చింది? వాట్ ఈస్ ద రీజన్ బిహైండ్ దిస్? ఎర్లియర్ మన ఎన్హాన్స్మెంట్ ట్రాన్సిస్టర్ వాడితే ఇక్కడ అప్పుడు యు గాట్ లైక్ దిస్, బట్ యు గాట్ సో వాట్ ఫుల్ VDD. ఎందుకు వచ్చింది చెప్పండి. హలో,
సరే సార్
చెప్పండి. భవ్య 26.
Yes, sir.
మీరు చెప్పండి. హలో,
Yes, sir.
మీరు చెప్పండి, ఎందుకు వచ్చింది ఫుల్ VDD? ఎలా వచ్చింది? పవన్ మీరు చెప్తారా? పవన్.
Like gate source direct connection.
నో. శృతి, శృతి.
సార్ డిప్లీషన్ మోడ్ లో ఉండడం వల్ల ఇది M2 అనేది ఆల్వేస్ ఇన్ సాచురేషన్ సార్.
ఓకే, ఎర్లియర్ కూడా మనం సాచురేషన్ లో పెట్టాం కదా. ఎర్లియర్ ఒక మోడ్ లో సాచురేషన్ పెట్టాం కదా.
ఇక్కడ గేట్ ఇంకా సోర్స్ కనెక్ట్ అయి ఉంటాయి కదా సార్.
నో. భారతి, భారతి. భారతి. శశికాంత్. ఓకే, సి 1 minute. So very simple. Satyanarayana, Raju.
Yes, sir.
Yeah, can you give the answer? Why you got full VDD at the output? ఈ కేసులో ఫుల్ VDD వచ్చింది, ఇంతకు ముందు రాలేదు. ఇక్కడ ఎందుకు వచ్చింది? బికాస్ ద లోడ్ ఈజ్ వాట్? చెప్పండి, లోడ్ ఈజ్ వాట్? చెప్పండి, చెప్పరేంటంటే వాట్ ఈస్ ద లోడ్? డిప్లీషన్ మాస్ఫెట్. డిప్లీషన్ మాస్ఫెట్ లో ఓకే ఛానల్ ఉంటుందా ఉండదా? హలో, శృతి, భవ్య, మీరందరూ చెప్పండి. డిప్లీషన్ మాస్ఫెట్ లో ఛానల్ ఏం జరుగుతుందో, ఉంటుందా ఉండదా? ఛానల్ ఈజ్ ఆల్వేస్ ప్రెసెంట్. ఆల్వేస్ ప్రెసెంట్. నోట్ నీడ్ టు ఎస్టాబ్లిష్ ద ఛానల్. డిప్లీషన్ మాస్ఫెట్ గురించి చెప్పినప్పుడు కూడా మీకు అర్థం కాలేదా? డిప్లీషన్ మాస్ఫెట్ లో ఛానల్ అనేది ఆల్రెడీ ఉంటుంది. ఓన్లీ యూ కెన్ వైడన్ ఆర్ వాట్ యూ కెన్ రెడ్యూస్ ద విడ్త్ ఆఫ్ ద ఛానల్. మీరు రెండు పనులు చేయగలరు. ఇంక్రీజ్ చేయొచ్చు విత్ ని ఆర్ డిక్రీజ్ చేయొచ్చు ఛానల్ విత్ ని. బట్ ఛానల్ ఈజ్ ఆల్వేస్ ప్రెసెంట్. ఛానల్ ప్రెసెంట్ అయిందంటే థ్రెషోల్డ్ వోల్టేజ్ అవసరం లేదు. సో ఇంతకు ముందు ఎన్హాన్స్మెంట్ ట్రాన్సిస్టర్ వాడాం కాబట్టి, ఎన్హాన్స్మెంట్ లోడ్ కాబట్టి, సో దానికి ఛానల్ ఎస్టాబ్లిష్ అవడానికి సమ్ వోల్టేజ్ కావాలి, అదే VTH2. అందుకే ఇక్కడ ఇన్స్టెడ్ ఆఫ్ VDD యు గాట్ VDD minus VTH. బట్ నౌ దిస్ ద డిప్లీషన్ మాస్ఫెట్. డిప్లీషన్ మాస్ఫెట్ కి సో నో నీడ్ ఆఫ్ థ్రెషోల్డ్ వోల్టేజ్ బికాస్ ఆల్రెడీ ఛానల్ ఇస్ దేర్, సో దట్ ఇట్ ఈస్ ఆల్వేస్ కండక్టింగ్. ఓకే, either increasing direction or decreasing direction. That is the reason. అర్థమైందా? హలో, హలో.
Yes, sir.
అర్థమైందా లేదా?
Yes, sir. Yes, sir.
ఎంజాయ్ ద డే. ఓకే, బాయ్. మీరు ఏంటండి రెస్పాన్స్ ఎవరు చాలా మంది రిమూవ్ చేశాను నేను. చెప్పట్లే, హ్యాపీగా ఆన్ చేసుకుని వాళ్ళ ఇంట్లో వాళ్ళు ఏదో కూరలో వంట ఏం చేసుకుంటున్నారు. ఓకే, ఐఎమ్ స్టాపింగ్ హియర్. గాట్ మై పాయింట్? హలో.
Yes, sir.
Yeah. So next class you have an exam, quiz. Okay, quiz exam. Understand? దేనికి ఊ అనరు.
Sir, yes, sir.
అడుగుతూ ఎన్నిసార్లు చెప్పినా మీకు మీ ఎవరినండి మీరు మీకు అర్థమైందా లేదా, మీకు ఇన్ఫర్మేషన్ రీచ్ అయిందా లేదా, అదే మీకు ఓన్లీ మీ వాక్కుంటూ వెళ్ళిపోతే హౌ డు వి నో? ఓకే, ఎనీహౌ. సో నెక్స్ట్ వీక్ అదే నెక్స్ట్ క్లాస్ లో చివరి 10 minutes లో క్విజ్ ఎగ్జామ్ పెడతాను. బీ ప్రిపేర్. ఓన్లీ సెకండ్ మాడ్యూల్ లో ఇంతవరకు అయిన సిలబస్ మీద క్విజ్ ఉంటుంది. ఓకేనా?
Yes, sir.
It is our responsibility. Who knows, who understood the message very well, they should spread to the others. Okay?
Okay, sir.
Okay, done.